All right, let's look at limits of oscillating functions. I think these are really fun because we have the oscillation of our trig functions, right? We're going around the circle and around the circle. And then we have some other element of maybe we're growing or shrinking. Um, and that's what the exponential controls. So let's see what happens to this function. The only real way to tell what the limit is, um, I think, is to graph it. So let me go to my graphing app. Best graphing app for the iPad ever. Not sponsored. Gosh, I'm so funny. Okay, anyway, y equals, typed in the function, go to graph, and bam. See how this thing's going back and forth and back and forth, and as we go to the right, it's growing and growing, but it's going up to the highest positive amount, and then down to the negative amount, up to the positive amount, down to the negative amount. So as we go to the right, it's technically going to like positive and negative infinity, but that's not a thing, right? We want to know exactly where the function's going. And if we don't, well, then we're going to say that the limit doesn't exist. So going back here, the limit of our function as x approaches infinity, so as we're going to the right, this one doesn't exist. Sadness. But when we look at the function as we go towards negative infinity, as we go to the left, well, we're oscillating. Well, it looks like we're approaching 0. And it's oscillating and oscillating closer and closer and closer and closer to 0. Thus, the limit equals 0. Right? And it makes sense that we grow when we go to the right, because if I were to plug in a really big number for x, well, our exponential is going to grow really big. And then if we were to plug in a negative number, right, well, e to the negative 5 is 1 over e to the 5th. And so our fraction there would get really, really, really small. So that's why we're getting closer and closer to 0 as we go to the left. Kind of cool.